Okay, so it started. Good morning, all. Today we'll see 8086 architecture. So before going to that, we know that we are having physical address of 20 bit. We have already seen memory segmentation, right? But we can't use this 20 bit. So because of we are using virtual address, we are not using physical address. And because of this memory segmentation, it gives the birth of file name concept that we have already seen. Yes, because we are using virtual address, that is base address colon offset address. Base address is of 16 bit, offset address is of 16 bit. If you want to get physical address, your base address is multiplied with 10 and added in offset address. Yes, hello.
Yes, sir.
Yes, this we have already seen. Okay. uh, Now, because of this, the one example was already given. Suppose in book, I want to go to chapter 5, which was on page number, suppose 100 or 400. Instead of that, we can go to chapter number 5, page number 15. Like that, we can go. That is our virtual address that we have already seen. So, chapter number is our base address. The page number in that chapter, particularly, is our offset. That's how we can do the calculation. This part we have already seen, so we'll not go into detail because we have seen yesterday quite in detail. Right now, this is the architecture of 8086. This is the upper part. This is called BIU, bus interface unit. Now, as you can see over here, it will look like this. The memory is attached with this. This is a arithmetic unit. You can call it as ALU also. These are the registers inside your microprocessor, and this one is Q. This is called prefetch Q. Okay, so first thing is this: why this ALU is needed? Because already we have seen we need to calculate physical address, right? So this ALU is doing the same task. Okay, first thing that you need to understand is what is the like why BIU is needed. BIU is used to fetch the instruction. As we have seen, any processor is doing only three tasks: fetching, decoding, and executing. Yes, hello.
Yes, sir.
Okay, so fetching part is done by BIU. Now, when BIU fetch the instruction from memory, okay, yes, that instruction is put on data bus. Okay, then why this is needed? Because from where I need to fetch the instruction, I want to know that. So that can be calculated in code segment plus IP, instruction pointer. Code segment is my base address of code segment address. This is offset. This is 16 bit, this is 16 bit, this is CS 16 bit register, this is IP 16 bit register. I need to calculate 20 bit address because in memory everything is in 20 bit, right? Address is in 20 bit. So that work is done by this ALU. That's why this ALU is here. Understand? Hello.
Yes, sir.
This ALU is performing calculation of physical address using virtual address. Okay. Now here in BIU we are having five registers: CS, SS, DS, ES. All four are segment registers. IP is our offset register. These segment registers will give us the starting point of each segment in memory. Keep in mind that will be in memory. Segments are in memory. These are the registers which gives the starting address. Okay, all are 16-bit register. Clear? Hello.
So, for this explain, Doran.
All these registers are of 16-bit. That is clear. Yes.
Yes, sir.
Okay. Out of these five registers, these first four are segment registers. This will give us the starting point of each segment. Actual segments are in memory. They are not in this. These are only registers which gives the starting point in memory. Done?
Yes, sir.
Yes. Okay. Now, once the okay, one more questions. Like we are having one ALU here, we'll have one more ALU in the EU execution unit also. Then why we'll have this two ALU? Can't we use single ALU? Can someone answer me? Why these two ALUs are there in 8086? Can't we use single ALU unit? We can't, because the one which is available in execution unit is used for execution of instruction, and we are doing parallel processing. We are fetching and executing parallelly, right? So if you want to do pipelining, you can't use single unit for both the purpose. That's why we are having separate unit to count the physical address. Yes. Hello. In 8086, we are having two ALUs, one in execution unit, one in BIU. Why? Because this will be used for execution purpose, this will be used for counting physical address. Now we are fetching and executing at the same time. That's why we can't use single ALU for both the purposes. That's why we are having two separate ALUs. Okay, and this will serve the purpose of pipelining. Okay, understand? Yes. Hello. Hello. Give me a minute. I will just come in a while.
Yes, sir.
Are you able to hear me? Hello. Okay, sorry, the
Yes,
power
sir.
is off here, so let me start recording again. Screen sharing. Okay, so are you able to see my screen now? Hello.
Yes, sir.
Please speak, because your power is not there and I'm not able to understand that you are getting it or not. So better just responding, okay? Respond to this. So this part is clear. Why we'll have two ALU? Hello. Hello.
Yes, sir.
Please
Yes,
speak,
sir.
otherwise we'll stop this session and you can leave. So is it clear why we are having two ALUs?
Yes, sir.
Yes, sir.
Now next is we are having this prefetch queue. So why this prefetch queue is there? Because what is the work of BIU? BIU will fetch the instruction, put it in this queue, After queue, like it gets full, it comes to control section, and then it is goes to execution unit. Okay, this is the flow. So that is written: fetch the instruction, calculate the physical address, manage the prefetch queue. Now what is prefetch queue? Okay, what each registers can do, we have already seen, right? All segment registers and IP addresses of 20 bits that we have seen. So that is done. Okay, next instruction comes through data bus. That is also clear. Now stored in prefetch queue. Now what is prefetch queue? So while we are executing one instruction, at the same time we'll fetch the next instruction and put it in a queue. Why in queue? Because the instruction which is fetched first should come to the execution unit first. So first in, first out. That is the concept used by queue. That's why it is queue, not stack. Okay, that's why we are using queue there. Now our queue, if you can see here, it is of 6 byte. Each box is 1 byte. Okay. Now first question is, why is it of 6 byte only? Can someone tell me what can be the reason of making that queue of 6 bytes? So at a time, we can fetch maximum 6 byte of data in that queue in advance. Okay. Hello.
Yes,
Hello.
sir.
Okay. So now why queue is 6 byte only? Because the maximum size of any instruction in 8086 is 6 byte. The biggest instruction is of 6 byte only in 8086. That's why the queue length is 6 bytes, so that we can accommodate the maximum size instruction also. Okay, this is the reason. Now, as I said, instruction is of 6 bytes. So thing is, different instructions are of different size. Okay, suppose this is my instruction, move BL, CL. Now, in the background, we need to convert this instruction into binary, right? Yes. Hello. Hello. Are you there?
Yes, sir.
Yes, sir.
Okay. So every instruction in the background contains opcode. Okay. So we need to convert this thing into opcode. So move BL, CL will contain one opcode. Okay. So this instruction is of 1 byte only. This is just the example that I'm giving you, right? Now, suppose I need to do instruction like this, move BL, Z25H. So what this instruction do? This instruction will copy this 25 into BL. Thing is, now our opcode, we can't make the opcode for this full instruction, right? If opcode is for full instruction, then I need to make new opcode for BL, 26H also, BL, 27H also. So that is not possible. So our opcode will only for move BL. So that will tell our processor that you need to move the data. Okay. Where you need to move the data into BL. Okay. And this data will come in the instruction itself. So 25 will be stored in the instruction. So we have one opcode for move BL and we have some data for 25H. So this instruction is of 2 byte. 1 byte will be required for 25. 1 byte will be for opcode. Understand? Hello? Are you there?
Yes, sir.
So this instruction is of 1 byte because in single opcode we can accommodate all this data. This instruction is of 2 byte because we can't accommodate full data. We have opcode for this part and this part need to be stored alone. Suppose we have this move bx, 16-bit data. So this move bx, we have one opcode, so it requires 1 byte. Now this is already a 2 byte data, so we need 2 byte for this. So total we require 3 byte. What I'm trying to tell you is every instruction can be of different size in 8086. The biggest instruction which require maximum size is 6 byte. And because of this, our queue size is 6 byte. Done? Hello?
Yes, sir.
Okay, what our queue is doing? Queue is prefetching the instruction in advance. Okay? Yes? Hello? Hello?
Yes, sir.
Okay, now next. What if pipeline fails? We have already seen in our pipeline session that if this is my normal program flow, right? Currently, I'm executing this line and I have already prefetched these instructions. Okay. And suddenly, because of this instruction, this is a jump instruction and I need to jump over here. So all this instruction that I have prefetched is useless now. So what happens if pipeline fails? In that case, you need to flush or remove all the data from your queue. You need to make your queue empty. Clear? Hello? Done? Hello? Am I audible?
Yes, sir.
So if pipeline fails, you need to remove all the data. Done? Hello? Please respond. Okay, now what? Can I fetch the half instruction in advance? Can I do that? Suppose there is one instruction as we have seen. This is the instruction is of 3 byte. This is my prefetch queue. Okay, it is already full. 1, 2, 3, 4 is full. I am having now only 2 space available, 5 and 6. Can I fetch this instruction? This is a 3 byte instruction. Can I do that? Hello? Hello? Are you there? Hit this, sir. Are you there?
Yes, sir.
Please respond. Don't sleep there. Okay, all of you. If I am having a queue which is currently full with 4 bytes, now I am having 2 bytes available, 5 and 6. And my next instruction is of 3 byte like this. Can I fetch this instruction?
No, sir.
Why?
2 byte જ available છે ને 3 byte fetch કરવાનું.
Okay. So thing is, for our case, we are not concerned about how many byte instructions is there. We simply having 2 bytes available, so we'll fetch that 2 bytes. Okay, and 1 byte will fetch it later on when this will get empty. Okay, so in 8086 is instruction is half also, then also we can fetch it. Okay, keep this in mind. Done? Hello? At the end, everything in memory is in byte form. Okay, 1 byte, 2 byte, 3 byte, 4 byte. We don't know the size of instruction, so whatever bytes are available, we'll access it till we'll get the 6 byte in our prefetch queue. So if instruction is half, still we can fetch the instruction. Done? Hello? With
Yes, sir.
clear? Yes?
Yes, sir.
Okay, one more question. When BIU refill the queue, मतलब આ queue છે એમાં હમણાં 1 થી 5 blocks busy છે. We are having 1 block empty. Can we fetch right now next instruction or not? Because see, if instruction is of 5 byte or 3 byte, we don't care, right? We can fill it, as we have already discussed that half instruction can be filled. So this 1 block is empty. Can we fill right now? Hello? Hello? Hit. Hers Gandhi. Am I audible?
Yes, sir.
Yes, sir.
Okay, so if
Yes.
1 byte is empty, we can fill, but we'll not do that. Okay, so if 1 byte is empty in our queue, we'll not fill it up. Why? Because 8086 is 16-bit processor. We can operate on 16-bit data at a time if we want. If we fill this block, again when it gets empty, we need to fill it up. So for filling up 16-bit, we need 2 clock cycle. But as 8086 is 16-bit processor, we can do it the same thing in 1 clock cycle. Then why to waste 1 clock cycle extra? So what we'll do is we'll wait for 2 bytes to get empty maximum. And once 2 bytes get empty, we can fill it up in a single shot. So in 8086, data get filled up after you are having 2 bytes free. Okay? Yes? Understand?
Yes,
Hello?
sir.
Yes, sir.
Yes.
Okay, so again, just for the sake of revision, let me explain you what happens. First, processor, this is BIU part, so it is fetching the instruction and decoding in control section or control unit, and then it gives to EIU or EU, sorry, execution unit. What happens? From the code segment, an instruction pointer will fetch the instruction. That instruction comes to data bus. That data bus put this instruction into queue. From that queue, that will come to control section. Control section will decode it and give it to execution unit for execution purpose. While execution unit is executing one instruction, at the same time, our next instruction will get fetch from memory. Here using this ALU, we are counting the physical address. It is given to queue and this process continues. Done? Now, as far as queue is concerned, we are having 6-byte queue. Why? Because the maximum size of our instruction is 6-byte. You can prefetch half instruction also. Okay, we only fill this queue when our 2 bytes are empty. Otherwise, we'll not fetch. Why? Because in single clock cycle, you can fetch 16 byte. Then why to waste one more byte? That's why we'll wait for 2 byte to get empty. Done. If our pipeline fails, we'll remove this content of queue and we'll fill it again. Done. Hello.
Yes, sir.
This stuff is clear. Hello. This much is clear. Hello.
Yes, sir.
Yes, sir.
Okay, now next is the bottom part is called execution unit. So now once we are having the instruction, that instruction comes on these lines. Okay, this is given to ALU. ALU will use it, execute it, and give it to here. These are our registers. Now concentrate on these registers. As you can see, these are 16-bit registers. Okay, SP, BP, SIDI. We have already seen in our last session that these are segment offset registers, right? BP and SP are for stack, SI is for data, DI is for extra segment. So these are our offset registers. So we can't do much with this. This is not available to user. While above register, these registers are actually very important. These are called general purpose register, and these are used by programmer to do program. As you can see over here, these are written in two parts, AL, AH. So L is for lower byte, H is for higher byte. So A register lower byte 8-bit, this is again 8-bit, and total full register is called AX, is of 16-bit. Same way BX, CX, and DX. So AX, BX, CX, and DX are 16-bit general purpose register. If you want to use it like that, if you want to use it like L and H, lower byte and higher byte, you can do 8-bit operation also. Understand? Hello? Hello? Are you there?
Yes,
Hello?
sir.
Okay, we'll explain
Yes,
you
sir.
again in detail. Don't worry. Now, keep one more thing in mind. We are using Little Indian structure. What do you mean by Little Indian structure? The higher byte will store in higher register, lower byte will store in lower register. What that mean? If I'm having number 1, 2, 4, 3, H, this 43 is lower byte, 1, 2 is higher byte. So if I want to store this number into AX register, this is my AX register, this is higher byte, this is lower byte. So lower byte will go in lower register, so 43 will go here, 12 will go in AH. Understand? Hello?
Yes.
Okay. Concentrate here. See. So we'll go to now programming little bit so you can understand what each register do. Now, again, move instruction is doing what? Copy the content of right hand side into left hand side. Keep this in mind always. The right hand side is the source, left hand side is the destination. So move CL comma 34H. What it will do? It will copy. This is my CX register, this is CH, this is CL. So 34 will be stored in CL. Done? Hello? Are you there? Hello?
Yes, sir.
Yes,
Okay, now
sir. Yes, sir.
move CH comma 12. So now 12 will be copied into CH. Done?
Yes, sir.
Now move BX comma CX. So this CX register is copy into BX. So 12 and 34 directly copy into BX. Understand? Yes.
Yes, sir.
Okay, now these two operations are of 8-bit because we are transferring 8-bit data at a time. 8086 is 16-bit processor. So we can process 16-bit data also. So the same thing that you have done using these two instructions can be done using single instruction like this. Move CX, 1234H. And that will do the same thing. 1, 2, 3, 4. Yes? Hello. Hello. Are you there?
Yes, sir.
Okay. Again. Chalo. Let's. You just need to tell me the answer. This is my registers, and we'll check your knowledge. AX, BX, CX, DX. Move BL, 05H. Where my 05 will be stored? Here. Yes. Move CH, 10H. Where 10H will be stored? Here. Yes. Hello.
Yes, sir.
Move AX, 1211H. So 11 will come over here, 12 will come over here. Done.
Yes, sir.
Move C move CL, AL. So what happens? The content of AL will copied into CL. So 11 will come over here. Yes.
Yes, sir.
Move DX, CX. So what happens? Now 10, 11 will copy over here. Yes.
Yes, sir.
Understand? Now move move BH, DH. So now what happens? This 10 will be copied here. Done?
Yes, sir.
Okay, so this is how your 8086 works, and this is how you can use 8-bit registers also. You can use 16-bit registers also. Keep one thing in mind. You can transfer only 8-bit data to 8-bit registers, 16-bit data to 16-bit registers. You can't use 8 to 16 or 16 to 8. What that mean? Move CL, AX, not possible. Move AX, CL is also not possible. Understand? Hello.
Yes, sir.
Yes, sir.
In 8086, operations can be of 8-bit or it can be of 16-bit. It can't be of 8 to 16 or 16 to 8. Just keep this thing in mind. Done? Yes?
Yes, sir.
Okay, so this is clear?
Yes, sir.
Okay. Now, again, here we are having operands. So why we need these operands? This is temporary registers. So sometimes suppose there is one instruction called exchange AX, BX. So what it will do? It will exchange the content of AX and BX. But we know that we need temporary variable to do this. Yes? Swapping of two numbers. C program. Hello.
Yes, sir.
Swap A, B. Suppose this is my program. How you can do this? A equal to 10, B equal to 20. Now I want output as A equal to 20, B equal to 10. How to do this? In C, if you want to do this, how you can do this? So if you want to do this, you need one temporary variable. So temp is equal to A is equal to B, and B is equal to temp. Yes? This is what you do. Right?
Yes, sir.
So if you want to do the same sort of operation, you require temporary register. So that register is nothing but this operands. Okay? It is again 16-bit registers that ALU is using. We can't use it for temporary purpose to store the answer or to do this kind of operation. Next, we have flag register, which give us the status of last result. Now, this will study in detail in next lecture. Okay, so what flags do and how it will work, that will study in next lecture. It is again 16-bit register. Clear? Hello?
Yes, sir.
Okay,
Yes,
so
sir.
again, chalo. Okay, one more thing. Suppose I want to add these two numbers, 4 and 5. So move BL, 4, move CL, 5, add BL, CL, and you can write add CL, BL. Right? These two things are possible. Now, add instruction, how it works? Whatever is your destination, your answer will be saved in your destination. So it will add BL and CL. In upper here, this case, answer will be stored in BL. In this case, answer will be stored in CL. This is the difference in add instruction. Understand? Hello? Okay. You people are sleeping. So suppose move AL comma 05H. So what happens? These are my registers AX, BX, CX, DX. So this will contain 05. Done?
Yes, sir.
Move BL comma is equal to, sorry, move BL comma 06H. Suppose. So BL will contain 06. Complete?
Yes, sir.
Now if I write add AL comma BL, what happens? Answer is 11. Yes? Hello?
Yes, sir.
So it is B. So the B will be stored in AL because AL here. So here 05 will be overwrite and here will store 0B. Same thing, but if I write add BL comma AL and this line is not there, in that case 05 will remain as it is, answer will be stored here. Okay? Understand the difference between these two add instruction? Hello?
Yes, sir.
Yes, sir.
Your add instruction will add these two numbers and answer will be always stored in destination. Okay? Yes? Hello? Now, last topic for today's session, revision. Okay, so now again concentrate. If I want to do add BL comma CL instruction, so how it will do? It will first fetch. How it will fetch? It will count CS and IP value. Using ALU, it will edit, find physical address. It will go to memory and access memory using data bus. It will put that add BL comma CL instruction into queue. Okay, once it is in queue, it will go to control section where it will get decoded and processor will get to know that it need to add the two numbers. Yes, this much flow is clear. Hello,
Yes, sir.
this full thing is done in BIU. Done? Yes. Hello.
Yes, sir.
Then it comes to execution unit, EU. When it comes to execution unit, these all things are free. So again, next instruction is fetched and same thing happens. Now here in execution unit, this is in EU, BL and CL registers are accessed and data is put on data bus. Yes. Yes. Both
Yes.
BL and CL value go to ALU. Answer will be added. Okay. Control unit will be informed and answer will be stored in BL again. Okay. This is what happens in the 8086 architecture. So 8086 is doing nothing but fetch, decode, and execute. Done? Architecture is clear? Hello?
Yes, sir.
All of you clear? Hello?
Yes, sir.
Yes, sir.
Okay. Now there are some exercise that you are supposed to do. So write down this assignment because it will come in your exam for sure. Now this is the thing that you are supposed to do. Exercise number 1. Do the addition of 4 and 5 using 3 different methods. And you need to tell me which one is better and why. Like move AL comma BL can be done. Move AH comma 05 can be done. Right? So you need to tell me how to add these two numbers using 3 different methods and which one is better. First task. Search some on instructions on internet. You need to search 8086 instructions and you will get to know. This is your first task. Done? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Question number 2. If you have seen the architecture carefully, from Q, there is one arrow goes to control unit and this is one more arrow which can directly go to ALU. Not ALU, but here data bus. Okay. Then why this arrow is needed from Q to direct execution unit? So Q is directly attached with execution unit also. Okay. Why? You need to answer why. Okay, I will tell you the reason. Because we have seen the instruction move BL, 05H. Yes? Hello? Hello? Are you
Yes,
there?
sir.
Yes, sir.
And we have seen that you are having the opcode for move BL, not for 05, right? Hello? Are you there? Please respond. Hello? You want answer or not?
Yes, sir.
Then please speak. Okay. So if I'm having an instruction called move BL, 05H, this move BL is having opcode. So that my control unit will get to know that I need to move the data into BL, right? And what data I need to move, that I need to store in the instruction itself. So suppose opcode for move BL, assume that it is AFH. So here AFH is stored. At the same time, I need to store this also, because what data I need to move into VL, that I need to store. So 05H is also stored into Q as a part of instruction. Understand? Yes. And that's why it is to instruction. Yes. Huh? Ritul, yes. Hello.
Yes, sir.
Okay. So this AF will go to control unit, and my control unit will get to know that I need to move data into BL register. That is clear. But what data I need to move, that is also stored in instruction, so that I need to give it to my ALU. Otherwise, ALU will not get this 05H, and that's why this line is there. This line will give data to my ALU. Understand? Yes. Hello. Hello. Are you there? Please speak. Are you there?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Sleeping or what? This is one exercise. If this for like kind of response will be there, will give you half of the things in self study. Will not explain you. So better concentrate and answer me. Okay. Again, just for the sake of revision, see, move AX comma BX. If this is my instruction, okay, my control unit need to decide what this instruction is trying to say. So for this full instruction, I can have only single opcode. So suppose that is 1BH, 8-bit opcode. So using 1B, my control unit will get to know that I need to transfer the data from BX to AX. So I don't need to tell anything else. Fine to my processor. So this is my 1 byte instruction. Clear?
Yes.
Yes. But in case I am writing move AX comma 1 2 3 4 H, then I am having 8-bit opcode for move AX only. Suppose 1 H. So 1 will tell my control unit that I need to transfer some data into AX. Yes. But what data I need to transfer, that I need to tell into instruction. So now my instruction will look like this: 1 1 1 2 3 4. So by reading this 1 it will get to know that I need to transfer 16-bit data. Then using 1 2 and 1 3, it will transfer this data into AX. So that's why this is 3-byte instruction. Understand?
Yes,
Hello.
sir.
So in my queue, it will be stored like this: 11, 12, 30, or sorry, 34, right? So when 11 goes into control units, it will get to know that I need to transfer 16-bit data. This data is available in queue. So how my ALU will get that data? So that's why this line is there. So using that, this will come to my ALU. Understand? That's why that line is given. Yes?
Yes, sir.
Okay. So this is also clear. Yes. Now operands are temporary registers used by microprocessor only, that we have already seen. Can't use by programmer, that we have seen. Example is also given by me, so you are not supposed to do this exercise. Okay, so third is not there. Flag I am going to teach you, so that is also not there in your self study. These are the two assignments that you are supposed to write down in your notebook. First, add 4 and 5 using 3 different methods and tell me which one is better. Question number 2, why this line is there? Explain this thing in detail. Question number 3. Draw the pin diagram of 8086. Now 8086, as you know, processor is look like this. So 8086 will look like a single chip physically, and it has 14 pins available, 40 pins available. So you need to draw that 40 pin chip diagram of 8086. This is one more assignment. Clear? Hello?
Yes,
I
sir.
have given you total 3 assignments. Just for the sake of revision, let me write it again, and first let me stop recording. Otherwise, you will not see this video.